So the situation here is that we have a combustion analysis of a 0.798 gram sample of an unknown compound containing carbon, hydrogen, and oxygen. And this gives 0.627 grams of carbon dioxide and 1.539 grams of water. And the question asks, what is the empirical formula? So the first thing that we're going to do in this question is find the grams of carbon and hydrogen produced. And then we know the grams that lie in our original compound just because of the conservation of mass. So I'm going to start by finding the grams of carbon we produce. So I'm going to take 0.627 grams of carbon dioxide. I'm going to convert this grams of carbon dioxide to moles just using the molar mass. And then I'm only interested in grams of carbon. So now that I have moles of carbon dioxide, I have to convert this to moles of carbon. And this is done just based on looking at this formula and saying for every one molecule of carbon dioxide, we have one carbon. And then now that I have moles of carbon, I want to convert back to grams. So I do this using the molar mass. 1 mole of carbon is 12 grams of carbon. And I'm going to get that we have 0.171 grams of carbon being produced. And similarly, I can do this for finding the grams of hydrogen. So starting with 1.539 grams of water, we can convert from grams of water to moles. And then in a similar way, for every mole of water, we have 2 moles of hydrogen, just based on looking at this molecular formula. And then I want to go back to grams, so I use the molar mass. For 1 mole of hydrogen, I have 1 gram of hydrogen. So I end up getting that we also have 0.171 grams of hydrogen. So the second step is to find the grams of oxygen in the compound. So you know the compound only contains carbon, hydrogen, and oxygen. So you can take the original mass that we have of the compound, subtract the amount of carbon that we know is in the compound, subtract the amount of hydrogen we know is in the compound to get the amount of oxygen. And we're going to get 0.456 grams of oxygen. So the next step is to find the empirical formula. And we're first going to do this by finding the number of moles of each component. So starting with carbon, we have 0.171 grams of carbon, and we're going to use the molar mass to convert to moles of carbon. And I get 0.01425 moles of carbon. And in my calculator, I don't round, I just plug in the values I get each time I go, but I'm just trying to show you guys some accurate values I'm getting. So then I'm going to do the same thing with hydrogen. And I get 0.171 moles of hydrogen. Then we're going to do the same thing with oxygen. And I get 0.0285 moles of oxygen. So the next thing that we're going to do is divide by the lowest number of moles. And the reason why we converted to moles in the first place is so we can find the ratios between each species that we need to find the empirical formula. So our lowest number of moles is 0.01425 moles of carbon. So we're going to divide each species by that value. And I have 1 mole of carbon. When I divide the 0.71 moles of hydrogen by this value, I get 12 moles of hydrogen. And when I do the same thing here, I get 2 moles of oxygen, and these are the ratios that allow me to find my empirical formula. So my empirical formula based on these values here is going to be CH12O2.